Welcome back. Now we are going to talk about poles and zeros before we even talk about the stability. So let's talk about poles and zeros. Okay, poles and zeros is poles going to help us, especially for in our stability problem. We'll talk about the stability in the next video, but I just want to give you the concept of poles and zeros. Oh well, by now you have looked at how to convert the time domain differential equation into a transfer function. So let's say we assume a transfer function g of s. In this case, let me pick up some numbers here. S plus 4 divided by s squared plus 6s. Okay. So let's say this is our transfer function. All right. Now the question arises, how do we find the poles and zeros from this transfer function? Well, first of all, let's define what a zero is going to be. Well, 0, as the name implies itself, is the value that is going to make this transfer function 0. In other words, how this transfer function g of s will become 0, right? The only way we could think about it is if s plus 4 is equal to 0, right? If s plus 4 is equal to 0, then this transfer function is going to be 0. So we call this, the one on the top is the numerator. If the numerator is equal to 0, s plus 4 is equal to 0, then the 0 is at s is equal to minus 4. Okay. And sometimes we also have a graphical symbol to represent that 0. We just represent it by a circle like that. Okay, looks like a 0 too, just don't cross a line on top of that. So just to make it clear, s plus 4 is equal to 0 is when the transfer function becomes 0. So this is called the 0 of that transfer function. So the 0 of that transfer function is when s is equal to minus 4. Now what in the world is a pole? Well, a pole is whatever makes the function, the transfer function, infinity. So g of s, what will make g of s goes to infinity? Well, the g of s could be at infinity obviously when the denominator is equal to 0. Anything divided by 0, if you recall from your math course or some other course, will make it infinity. So the only way we could do that is when s squared plus 6s is equal to 0. So one more time, pole is nothing but if your transfer function, whatever the value of the denominator is going to be, that makes the function, transfer function, goes to infinity, and the only value you know is anything divided by 0, so s plus s squared plus 6s is equal to 0. Well, we can solve this equation now, right? So we can factor out the s, and you will have s plus 6, and this is what you got, right? So in reality, this has got two poles. One is at s is equal to 0, and the other one is at s is equal to minus 6. These are the poles. And poles are represented symbolically by a cross like this. So pretty interesting concept here. Sometimes we also would like to do a pole zero plot of the function. Well, what was the original function? If you recall, the original function was s plus 4 divided by s squared plus 6s. So let me write this down again. So the original function is s plus 4 divided by s squared plus 6s. Well, like I said in the beginning, we can factor this out at the denominator, the s, so you are going to get s plus 6. Okay, s times s plus 6. How do we plot this? It's called a pole zero plot. So let me write this, pole zero plot. Pole zero plot. Okay, So let's plot this. You're going to have the real axis and the imaginary axis. So here you have the real axis. This is the real. Let me write down this as real. And this is the imaginary. IMG is enough, right? And here is your origin right there. So you can see that there is a 0 on the left hand side at -4, 1, 2, 3, and 4. So -4 is right here, and remember you put a circle there because there is a 0 at -4, and then there is a pole at -6, so 5 and -6, so you put a cross like that. And then in this transfer function there is also a pole at the origin. So this kind of gives you an idea about the pole zero plot and poles and zeros of the transfer function. So the bottom line here is that the 0 is when the transfer function becomes 0, and that can only happen when the numerator is equal to 0. And when the transfer function goes to infinity, that can only happen when the denominator is equal to 0. So with that, I'll see you in the next video and we'll talk about the stability. Thank you.